Welcome to Two Projects. In this video, we are going to explain the project Emotion Detection from Microblogs using Novel Input Representation. Before diving into the execution, let me give you an overview of the project. So, emotion detection from microblogs refers to the task of identifying and categorizing the emotions expressed in short form social media posts, particularly microblog posts like tweets. So these posts are usually concise and limited in length, making them challenging yet valuable sources of emotional expression. Emotion detection involves analyzing the text of these posts to understand the underlying emotional states of the users who authored them or posted them. So, microblogs are platforms where users can post short form content, typically limited to a certain character count. So, Twitter is one of the most well known microblogging platforms where users can share thoughts, opinions, and updates. Microblog posts often provide a glimpse into the emotions, feelings, and moods of users at the time of posting. For example, a tweet expressing frustration about a delayed train or a Facebook status celebrating a personal achievement both convey different emotional states. Analyzing these posts can offer valuable insights into the collective emotional pulse of a community or society. So, in this project, the focus is on detecting a range of primary emotions commonly expressed in microblog posts. These emotions include sadness, anger, love, happiness, surprise, and fear. So, by accurately classifying these emotions in microblog posts, the project aims to provide a deeper understanding of user sentiments, which can have implications for various fields such as market research, social media analytics, and mental health monitoring. So, traditional methods of understanding text struggle with grasping the subtle emotions in short social media posts. These methods rely on simple rules or lists of words which don't work well with the informal language and context found in the microblogs. And microblog posts are casual and often don't give much background information. People use different slangs and emojis a lot, which can be hard for basic traditional methods to understand. Plus, the context around a post, like recent events, influences its emotional meaning. So, there comes machine learning and deep learning. So, machine learning and deep learning can handle these challenges better. They learn from lots of examples to understand the complex patterns in the text. Unlike traditional methods, they can adapt and learn from new information, which helps them understand emotions in microblog posts more accurately. So these methods can pick up on subtle clues in the language and context of microblog posts. By analyzing lots of data, they can figure out the emotions being expressed more accurately than traditional methods. So we will be using machine learning and deep learning algorithms in this project for emotion detection. Now we'll look at the workflow. So the dataset used in the project is microblog posts dataset, usually from Twitter. So before training the models on this dataset, we will clean or pre-process the dataset. So the first step in the workflow is data pre-processing, which includes removal of duplicates, that is removing any repeated posts, cleaning up the text by getting rid of unnecessary stuff like emojis or web links, and organizing hashtags. Later, we use graphs and charts to understand the data better. This helps us see how different emotions are spread out in the data and choose which parts are most important for a model to look at. Then we will tokenize the data. So, tokenization is the process of breaking down text into smaller units such as words or phrases to prepare it for analysis. We employ two tokenization methods, TF-IDF vectorizer, which converts text into numerical vectors based on word frequency, and Another method is Keras tokenizer, which tokenizes text specifically for deep learning models. And to improve model performance and efficiency, we select the most important features using feature selection techniques. This ensures that our models focus on the most informative aspects of the data. Later, we will split the dataset into two parts, one for training our models and another set for testing how well they work. So, this helps us make sure our models understand emotions well, not just memorizing the examples we give them. And we develop models using both traditional machine learning algorithms and deep learning architectures. So these models are trained on the training data and evaluated using various performance metrics. By comparing the performance of different models, we can identify the most effective approach for emotion detection in microblog posts. So this is what happens in this project. Overall, the project aims to create a system that accurately understands and categorizes emotions in short social media posts. The system will be helpful for social media platforms, researchers, psychologists, and others who want to understand how people feel online. The system's accurate emotion classification will enhance sentiment analysis, market research strategies, and mental health monitoring efforts. Now we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language needed is Python, front-end framework required is Flask, back-end framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll look at the algorithms built. So in the base paper, author has proposed this model which utilizes the SMORT algorithm along with systematic analysis and sentiment feature techniques. It combines three machine learning models, random forest, support vector machine, and XGBoost. So he compared this proposed model with these individual models, random forest, SVM, KNN, and XGBoost classifier, and with these ensemble models, which are built combining different models. So he concluded that the proposed model has outperformed other models. So for improved performance, we are proposing deep learning models, LSTM and combination of LSTM and GRU in this project. We will be building all these models, the models proposed by the author and the models which we are proposing, and we'll compare their performance and select the best performing one among all for emotion detection. Now we'll understand about the algorithms which we have proposed. The first one is LSTM. So LSTM or long short-term memory is a type of neural network designed for processing sequences of data like sentences or time series data. What sets LSTM apart is its ability to retain information over long periods, which is particularly useful for understanding the context in sequences. It achieves this through its architecture, which includes a memory cell capable of storing information, along with gates that regulate the flow of information into and out of the cell. So, these gates enable LSTM to decide what information to keep or discard, allowing it to capture long term dependencies in sequences effectively. Next comes combination of LSTM and GRU. So LSTM with GRU combines LSTM architecture with the gated recurrent unit, that is GRU, which is a simplified version of the LSTM. GRU merges some components of LSTM to reduce complexity and computational overhead while still maintaining the ability to model long range dependencies in sequences. So this makes it suitable for tasks requiring sequence processing such as analyzing emotions in short social media posts. So, this is about the models which we have proposed. After building all these models, after training all these models and evaluating their performance, we have observed that the combination of LSTM and GRU has outperformed all other models in all the performance metrics. So we will be deploying this model into the Flask web application. And we have used latent dirichlet allocation, that is LDA topic modeling technique in this project. So LDA helps to uncover common themes or topics present in a set of documents. Instead of manually assigning topics, LDA automatically identifies them based on the words used in the documents. It does this by looking at how words co-occur across the documents and grouping them into topics. So these topics can then be interpreted to understand the underlying themes present in the text. So we will be executing the project in the Flask web application. Before executing the project, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is a static folder which consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is data file which contains required dataset. So here I have two columns, text and emotion. So in the text column, I have microblog posts, usually tweets. And in the emotion column, this is the target column, I have respective emotions. So I have five different classes or five different emotions in this dataset, that are sadness, love, surprise, happy, fear, and anger. So on this dataset, we will be training the machine learning and deep learning models. So before training the models, we will split this dataset into two sets, train and test sets. Train set is for training the models and test set is for evaluating their performance. So this is about the dataset. These are model files which contain algorithm information. So these files will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is processed file in which I have the same dataset which is processed. This is sample file in which I have test cases on which will make the predictions, the classifications. This is signup.db file. This file is the database file used to store user information. It stores information like signup details. And this is topic modeling Python main code file for LDA. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path, copy it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first, fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the classification page. Here we can see a enter your message box where we have to enter a message or we have to input any microblog text post, and the application will detect the emotion in the given message. I have entered this message. Now click on submit button. I have took this message from the sample file in which I have test cases. So this is the message I have given. And here we can see the detection, that is emotion for microblog content is happy. So the application has detected the emotion in this message as happy. And dependent upon these words, the application has detected the emotion as happy. Click on home. We'll try giving another message. I have entered this message. Now click on submit button. This is the given text. And here we can see the detection, that is emotion for microblog content is sadness. So the application has detected the emotion in this message as sadness. And these are the words which have influenced this decision. So based on these words, the application has detected the emotion in this message as sad. We'll try giving another message. Click on home link. I have entered this text. Now click on submit button. This is the given input. And here we can see emotion for microblog content is surprise. So the application has detected the emotion in this message as surprise. And based on these words, the application has took this decision. Click on home link, enter the message here. This is the input I have given. So here we can see this time the emotion detected is love. This is the given message. And here we can see the emotion for given microblog content is love. And dependent upon these words, the application has took this decision. Click on home link. Similarly, we can give any message from the test cases and can get the detections of the emotion. I have entered this message. Now click on submit button. This is the message entered. And here we can see the label, that is emotion for microblog content is anger this time. And based on these words, the application has detected the emotion in this message as anger. We'll try with some more test cases. This is the entered message. Here we can see emotion for microblog content is fear. So the application has detected the emotion in this message as fear. And here we can see these are the words dependent upon which the application has took this decision. This is the message I have entered, and here we can see emotion for microblog content is love. And these are the words which have influenced this decision. This is the message I have entered. Now click on submit button. So here we can see the label that is emotion for microblog content is sadness. So the application has detected the emotion in this message as sad. And here we can see the words based on which the application has detected the emotion in this message as sadness. So in this way, we have to enter any message from the test cases and get the detection of the emotions. Now click on sign out. So we have developed an emotion detection system for microblog posts employing machine learning and deep learning techniques. By pre-processing data, building robust models, and employing advanced algorithms like LDA, it achieved accurate sentiment classification. Notably, combination of LSTM with GRU outperformed, enhancing the system's effectiveness in social media analytics, market research, and mental health monitoring endeavors.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.